Hey everyone, this is Prince from Desi Programmer, and in this video, we're going to talk about some REST API best practices that you must follow to make sure that your API is easy to implement, understandable, maintainable, and scalable. Let's get started with a simple topic, which is JSON response structure. When a client request is made via RESTful API, it transfers a representation of the state at that particular point. The information or representation can be delivered into several formats such as JSON, HTML, XML, or even plain text. Now, JSON is most generally popular file format to use. Despite its name, it's language agnostic and can be easily used by both humans and machines. Now, sending simple response data in JSON can really be seen as a very simple topic, which it is, but I've seen many times people making some really weird response and sending some really weird unstructured data. For example, if I make a request for user data, this is the kind of structure that you might use to send the user data. It has a name, username, number of subscribers, token, and email verified, right? But sometimes people send this data into really weird way. One common reason is because they just make the database call and thus assign that to a key and send it back, which makes the data really unstructured. This itself is very simple right now, but it gets worse when you are sending really complex data. For example, product data, if you want to send that, this could be considered as a very good structure. It has name, categories, which are simple string values, created description, diameter, and stuff like that. But I have seen many times people sending really weird data such as this one, where the first key value is correct, but categories, this was not necessary at all. Even at feedbacks, this was not necessary. You could have just made this data on the server side itself and then send the full name right in here. In variants, you are sending just one name while you should have sent at least the image, title, price, ID so that further data could be requested based on this variant, and so many such things. I know this was a really simple topic, but this is really important to send well structured JSON data so that it could be easily parsed on the client side and then can be used. The next point is HTTP status code. HTTP status codes are delivered to your browser in the HTTP header, while status codes are returned every time we make a server request. Most of the time, we either don't see them or we just ignore them. But when it comes to REST API, it's really necessary to take care of it. HTTP status codes can be broadly divided into 5 classes. So we have the 100s, which are simple informational code while the process is usually going on. We usually don't care about them. The 200s, which are success code returned when the browser request was received, understood, and processed by the server. We usually check that if the response status is 200, it means our request was successfully completed. Then there are 300s, which again we don't really use, but it simply means that the request was redirected to a new resource, a URL, or a server. We usually don't check for them in REST APIs. The most important one are 400s, which are client error that indicate that there was a problem with the request. And then there are 500, which simply means server error codes. Now this might not be very clear from this simple example, so let's take a practical example from a Laravel REST API course. Here, as you can see, there are many requests as in here. But if I go to register and if I click on send, it says that hey, there is an error that the email has already been taken. Pay attention to this particular status, which is 422, which says unprocessable content. Now if a client is going to make a request to this server, and they can easily check if the response error code is 422 or not. If it's 422, which means hey, you were sending data that was not correct. In the same way, there are many other HTTP status codes which can be used. For example, if I go to logout, if I click on send, it says 401 unauthorized, which means whatever the authorization token I used was not correct, and this means that the user should be logged out. You can simply send a get request and it will be 200 OK, which means hey, whatever request you made was successfully processed and now you can see the result. Now I have seen this many times that instead of sending the HTTP status code as 422, 401, 400, 200 or something as that, people usually send their own error code as in here. They give that a meaning. For example, if the error code is 0, it means it was an error. If error code is 1, it means it was successful. And you should never do that. It's always mandatory to make sure that you send the exact HTTP response code to make sure that your request's response could easily be understood by the client. There are many HTTP status codes which are really specific. For example, 201, which means that a resource was created. 402, which means payment is required for this particular resource, or 406, which simply means that the request was not acceptable. But I'm not asking you to go in that detail right now, but you should at least use simple HTTP status codes, for example 200, 201, 400, 401, 404 or 500s, 422. Request methods. While making simple web services, you must have heard about the get and post request method, and probably you might even know what that means. But when it comes to REST APIs, there are many other HTTP request methods that you can use, and it's really necessary and fruitful to use them. Let's take a simple example at that. For example, I have a simple API that creates, gets, deletes, and updates ideas. Now I've seen people simply put up their routes as ideas, which will get you an idea, a post request to idea, which will create an idea, but there is a delete idea, which is a simple get request, or maybe a post request with ID where you delete an idea, and another post request with the ID and data where you update an idea. Now that's okay, but it could be made great when you use something like a get request to get all the ideas, a post request to create an idea, a delete request to delete an idea with a particular ID, and a put request to update an idea with a particular ID. Now, there are many other HTTP request methods that you can use for specific purposes, but even if you're using this 4 or 5, then your API will really stand out, and whoever is going to use it or check it will understand that you have a very good understanding of the particular concept. Versioning your APIs. You might have seen about a product versions. The same can be applied to APIs too. And this is something that you should have commonly seen in APIs which are usually distributed by large companies or better programmers. Let's talk about this with a simple practical example. Let's say you made an app. The app simply stores the user's ideas. Now you have a simple API where you just ask the title and description, and then you create an idea for the particular user. It's going really well and your app became a success. Now people gave you many ideas of what you can do for a particular application, and now you made a really great application. But in that application, so many things could be done. Now your simple idea is not just a title and a description. Here you have added teams, tracking, and collaboration. So now your simple idea can have title, description, collaborators which can collaborate on this same idea, a group which means whether it belongs to marketing or engineering, deadline which could be a date of when this idea should be completed or have to be completed. Now versioning really makes it simple to make sure that when you make really drastic changes to your APIs or database, you can separate them so that they can be used by your web service or app, whatever it is, and then could be maintained easily. Now usually in a website, you can simply update your site and whoever visits it has to use your latest updated services. But when it comes to application, user might have an old version of the app and might be doing this while your database or your API are prepped according to this. This can obviously cause many errors. Your app can crash mostly for the existing users. Now, if you want to give them a better experience, you can do simple API versioning. For example, this could be your V0 of the APIs or maybe V1, and this could be your V1 of the APIs. You can also do something like forcing the user to update the application or simply ignoring this right here and adding a V1 right in here itself, which is great. But what would you do at the end? You may have to end up using versioning to make sure that all your users have a smooth experience and you can manage your app smoothly. Last topic is token authentication. So authentication is something that is handled very differently in a REST API than in a server-rendered website. Mostly in a server-rendered website, we use sessions to handle user authentication and authorization. But when it comes to REST API, we use something called tokens to handle user authentication. Something that people easily miss or ignore. You see, transitioning your knowledge from a simple server-rendering website to a REST API is fairly simple until it comes to authentication or uploading files. So in authentication, I have seen many APIs where they simply store the user ID in a local database of let's say an application, and then they assume that the user is logged in and then they use their ID to make requests to any resource or to create any resource, which works out well most of the time. But this poses serious security threats. Let's say I have this particular API where I just need these 3 data to create an API. Now my server is assuming that this particular user has access to whatever authorized application that I have published to create an idea. But if I intercept the API calls which are being made from your application, then I can simply make a request to this particular endpoint with this data and can create a resource for, let's say, a user with ID of 1234. A user which either may not exist or a user which may exist and can then later think that your product is not working properly. Not just that, this also make ways for hackers to tamper with your application, or most probably make sure that your services are down or you pay a lot more money for services which are not even being used by real people. Now there are different ways to handle token authentication, usually two of them, and I will talk about the first one right here. Simple token is something where you create a single token for a user and then you store that in a database. Something that can be checked against the user ID with each request. Now this process is simple and straightforward, but it has a risk of taking large response time, as there has to be database read with every particular request. The second one is using refresh token, where you create a small time alive auth token and a long time alive refresh token. So the small time alive auth token can be used to make requests to your server, but when the auth token expires, the refresh token should be used to create another auth token. Now this process itself looks complex and is a bit thought-provoking, but it's fast as there is no database read write every time. Now the refresh token concept itself need an entire video where we can talk about detail on how to implement refresh token and auth token. But since for the Laravel course we are simply going to use simple tokens, as Laravel provides that by default, and that actually fulfills the job that we have at this point, I'm going to leave this video right in there. But make sure to check out the entire Laravel REST API course, which I will be publishing today itself. And let's make really awesome backend web APIs. So that's pretty much it from my side in this video. This is Prince from Desi Programmer. Check out Desi Programmer Pro and check out the Laravel course, and follow me on Instagram to make sure that you can get all the updates on time.